Hello everyone, this is Murat, and today we are going to build a marketing referral system using Solidity, Hardhat, Ethersjs and NextJS. First, we are going to write a smart contract with Solidity and using Hardhat. Then we are going to write the front end with NextJS and the newest version of Ethersjs. First, I'm going to explain you what we are going to build, and I would like to add that this is kind of a special project for me because like 5 or 6 months ago, I'm not entirely sure, I applied to a Web3 developer job, and this was the take-home assignment that the company sent to me, and I for the life of me couldn't build this the application. I remember spending 3 days dabbling with upgradable proxy contracts, which were completely useless in this instance. Anyway, so if my understanding is correct, this project is suitable for a junior Web3 developer project. So after all these months, of course, I've been learning a lot of things, different things, and I thought to myself, I'm bored, what should I do? I want to build something with Solidity so that I can make a video out of it. And I thought, okay, I'm going to try to build this application, and yeah, I built it, and now I'm gonna teach you how to build it. So what are we going to build? The idea is, it's like a pyramid scheme, you know, a marketing referral system. So each user, these are the specifications they sent me for Binance Coin, but for the Binance chain, but we are not going to deal with Binance, so forget about this. Let's make this it. The idea is that you can only enter the system by referred by someone, and in order to enter the system you have to pay 0.25 Ether. After you enter the system, you can invite other people. When you invite someone, for the first 2 people that you have invited, you get the 70% of the 0.25 Ether that they pay, and the 30% goes to the smart contract, the contract wallet. For each third user, you divide the money you get for your referral 50-50. This happens 9 times for each level. So you start with level 1, and in order to level up, to go to level 2, you have to pay 0.05 Ether to the business address wallet. Then you are on level 2, and on level 2 you can do the same. You can refer 9 people. It goes the same logic, and you can reach 10 levels in total. So right now we are going to build this. So what do I have? Well, I have a project ready. I don't want to create it here, so but I will tell you how did I create it so you can do the same. Where am I? So I created an application using this command. Can you see it? npx create next app --tailwind --typescript and the name Marketing Referral. You can change the name whatever you want. Then I cd'd into, I waited for the completion of the packages to download. I cd'd into that NextJS. I created a backend folder. I cd'd into the backend folder. Inside that folder I run npm init y. After that I installed npm e-save-dev Hardhat, and after installing Hardhat I ran hh I just ran hh, which is npx Hardhat run, I guess. I can run hh because I have I've downloaded something globally that helps me do that. Let me see. It should be something completion. Just a moment. Compiling, testing, advanced, command line completion. Yes, but I cannot. Just a moment. Okay, I'm back. I had to close Firefox. It stopped responding. Anyway, so I installed this npm install -h global Hardhat shorthand from the Hardhat documentation. You can find it in this command line completion part, so that I can write HH and everything will work. Anyway, so we have a Hardhat project. So let's start writing our contract. Okay, I'm going to change the name of this to referral.sol, I guess. Yeah. So just a moment, I'm just checking if we are recording or not. I'm always checking things. So now I'm going to copy paste the very beginning of the oh yeah, I forgot to install OpenZeppelin too. So let's install this on the site. And yes, it's yes. We will need OpenZeppelin contracts, SafeMath, and reentrancy guard. As you can see, I start my smart contract with SPDX license identifier unlicensed and licensed. This is the compiler. We import these two, and we import Hardhat console log because we might want to use it. Is everything okay? Yeah. And contract referral is reentrancy guard. Okay, now we can start. So what do I want? I want to start by using SafeMath. Yeah, using. Yes. I want to create the user. Struct user. Structs are like objects in JavaScript. Yes. So this is the referrer. We are going to say uint 8 total referrals. Why uint 8? Because we don't need a big number. Uint 8, so we will spend less gas. And uint 256 earnings, because we don't know how much they will earn. I don't know. So I have my user struct. I would also like to start my. Oh wait, I will explain. Okay, just a moment. So let's think for a moment that you don't know anything about Solidity and you are a JavaScript developer. You don't even know TypeScript, and you want to understand what's going on here. I'm sorry if I started very in a hastily manner. In Solidity, you write your smart contracts, which are just pieces of code programs that run in blockchain with the .sol extension. You start with defining the license, then Solidity compiler, because Solidity is a compiled language, you have to compile it. Then here, these are very basic import statements. We are importing two smart contracts from OpenZeppelin. It's a let me open. It's. Can you see it? Just a moment. Can you see clearly? Maybe a bit bigger. Would you like it? Yeah. I think this is great. This is too big. No, this is too big for me. So OpenZeppelin gives us ready to use contracts like ERC20, which are fungible tokens, ERC70 721 NFTs and so on and so on. They have many things, so we are using we are getting help from there. This is a feature of Hardhat that will enable us to use console log if you want to, like as if we were writing JavaScript. Now these all contracts in Solidity start with the contract keyword, the name of the contract, and this this is like classes in JavaScript. You know, you can extend classes. This is the same thing. We are extending reintransit guard, which is a hacking type of hacking, our contract, and we are using this SafeMath library or contract for our Uint 256. Now struct user, as I said, structs are pretty much like objects. The thing with Solidity is that it's a typed language, so we have to define the type of the variable that we are going to create. So instead of just saying let const or var user, we have to say that this is a variable with the type of struct with the name of user, and inside of it our key value pairs, you know, instead of just adding referrer, I have to we have to define that this referrer is an address. This total referrer is to Uint 8, level is Uint 8, and earnings are Uint 256. These I guess take 256 digits or something like that. I'm not entirely sure. Like these will cost less than this one, and this is a very big number. Then I'm creating an another address, public owner, and Solidity has this syntax that JavaScript does not. This is mapping. Mappings are similar to, I guess, dictionaries. In JavaScript you can create them by yourself, but they are not native to the JavaScript itself. It's basically, you start with the mapping keyword, you define if it's private, public, whatever the name, and what it does is you pass an address to it, and it directs you to a user, and it's very useful. Like we will pass the wallet address and it will show us the user, so we can get all the information about the user there. Okay, let's continue. Now I want to add some constants. Okay, I'm going to copy paste and explain. We are going to use those. Do you remember our what we were going to build? We have a registration fee. Like in order to register, you have to pay 0.25 Ether. So we are defining this, and referral gets as referral you get 70% of it. We are going to see why this is so. You know, in every third we have to do something, so I wrote it like this. We are going to use it soon, and with each third user, you remember, you will divide the gains with the contract. Now let's start with our constructor. Just a moment. What's a constructor? Constructor is a function that runs only once at the beginning of deployment. Users, owner, nope. User, I'm going to copy paste this. I don't want to change anything. Now, what's going on here? We are creating. Sorry, I'm a little bit sick. We are creating a new user struct that does not a referrer. I'm passing the address 0 as a referrer because this is the owner, the address that deploys the contract. Therefore, it doesn't have a referrer. So address 0 is a null address in Solidity. It's a special type of address, and this will be only time that we'll use it. And then total referrals here. We are creating the struct by giving the values. Total referrals 0 because we haven't referred anyone. Level 1, yes. Earnings 0. Why? Because we didn't earn anything. So this is our constructor. Now we are going to write some modifiers soon, but first let's start with register function. So the thing with smart contract development, writing, once you get the idea, this is what I think. Once you get the idea how to write it, the underlying logic, it's not that difficult. It doesn't take too much time. You don't write hundreds and hundreds and hundreds of lines of code. Contracts are pretty compact, but the thing is you have to test them like crazy because they contain money. You are dealing with money, so you have to test them like there is no tomorrow. So we are creating a function named register that takes an address of referrer. This underscore is a convention, you don't have to do it, but it just is a parameter which is a public. That means this function can be called externally, and it's payable, which means that this function can accept money. Now this is the thing. See, we can accept money with it. Okay. Let's start with. So this is basically the register functionality. In order to enter the system, the premise scheme, the marketing referral system, you will have an address that says, hey man, like, come on, we have this thing, marketing, I would like to refer you. You can earn money with it, but first you have to pay money. So I'm gonna give you my address, and you can use my address to get into the club. So yeah, I'm going to start with creating a new user. Now, what is going on here? It's complaining because we haven't used it, but we are going to use it, so no worries. I'm creating a variable called new user that is stored in storage, which is a type of user struct that we have created here. So that is that equals to in the user's mapping to the address of message sender. I know that didn't make sense at all. Even I got confused, like what the hell is going on here? Basically, this means that this message sender is a built-in Solidity stuff. It is the address of the person or entity that's calling the function. So if you are calling the function, you are the message sender. So what this is doing, it will create a new user, and when I pass the address of that user, it will, as you can see here, I will pass the address, which is let's say it's me. It will be my address, and it will direct you to me because it directs to a user. That's what it's doing. I know that as a JavaScript developer, I have a background in JavaScript. If you haven't got it yet, this syntax is a bit weird, but you get used to it. This is what it does. Now, now let's. This is, yes. Now this we can understand. 0, level 1. So since we are creating our new user, we would like to give it some the values that the referrer, who is the referrer, we might want to keep a track of the referrer. How many referrals it has? 0, because they have just gotten. How many levels they have? 1. That's it. Now we can add some console logs just to show. We might play with them later on. They won't work right now. In order for them to work, we have to do this. So we will go back to that later. Now, just a moment. Now I put 2 more functions and it's complaining. You know why does it complaining? Because, well, I don't have those functions. So let's create let's start with creating the transfer payment function, and then at some point we have to modify our register function with modifiers, and I'm gonna explain what is that, how does it work and so on. Let's create our function transfer payments address referrer. I'm going to copy paste. No, and it's private. Why private? Because, well, why private? Because we don't need to call this function outside. It's being called by a function here, so we don't need to put it like public. This transfer payment function will take 2 parameters: an address of referrer and AUN 256 of amount. Who referred whom, and how much money will be paid with this function at the moment. Now let me, here we have to do some stuff, the best way is to copy paste, I guess. Yeah, so I have this referral amount and business amount. You know, you will remember we can only, for each level we can invite 9 users, and for the first these 9 users are divided by 3 into 3 groups. For each 3 users, the first 2, you as referrer get the 70% of the money, and the 30% goes to business contract, this contract, and for the third user you divide the money 50-50. So this is the referral amount, which is the amount times referral percentage, which is here we defined 70 divided by 100. So this is our basic math. I hope it's correct. I remember it's correct, but I tested truly, but who knows, maybe I made a mistake. And our business amount is the amount minus referral amount, because we got the 70% of the amount, and now we can just extract it from the total amount, and that will give us the 30% that will be paid to the business amount. Now we have to do some stuff here. If ugly stuff. Right. What is going on here? So if here we are dealing with the user's mapping, you know, this is where I used this is the part where I try to understand if it's the third user or not, because if it's the third user, I have to use bonus percentage, which is 50, and we will divide the money 50-50 with the business contract. So here I get the users mapping, I give the referrer address, so it finds me the struct, because that's what it does. You know, you give the address into the users mapping, and it directs you to the user, the struct of the user. And I'm checking if it has more than one total referrals, and if total referrals plus 1 modulus 3 equals 0. Don't ask me why I did it like this. I don't remember. This works, so you can think to yourself, how is this working, why is this working, etc. Modulus, if you don't know modulus, it's basically, if I have 3 here, if I 3 modulus is like, have you ever done FizzBuzz? Like, modulus gives the remnant of like 3 modulus 3 is 0, 4 modulus 3 is 1, because there are just 1 3 in 4, and when you take the 3 from 4, you are left with 1. 5 modulus 3 is 2, etc. So we are getting that here. This is the logic we have. Now we would like to pay referral. No, just a moment. Payable referrer transfer referral amount. Yes, exactly. And I would like to update the earnings also. Again, we are going to the struct by giving the user struct, by giving the address of the referrer here to users mapping. Here we are going to do struct it's referring to, and we are incrementing the earnings because we might want to keep track of it. And here, this is the transfer function, basically sends this amount of money to this address. So, and here, like these two make it. I'm going to copy paste the update referral count function. It's again a private function. Takes the address of the referrer, the person who is referring the current user. And again, here we have users mapping. We pass the address and it directs us to the user struct, and we are incrementing the total referrals unit 8 here. Now all is good. Actually, we wrote most of the smart contract. Like now we just need to add some modifiers. Let me again, why modifiers? Because like we don't want anyone to register, you know, like let's say you registered, okay, we don't want, we want only, for instance, someone who is invited to register. Also, when you register once, you cannot register again. You cannot register without having a valid address that has registered before and invited you. So we might need to, or if you don't pay the fee, you cannot register, and so on and so on. So I'm going, yeah, the best way is copy paste, because there's a lot of stuff going on here. I'm going to explain all of them. Now we have a modifier called valid registration. Let me first use it here so that I can explain better, hopefully. Now what did I do? What have we done? So I have a modifier and I'm passing this modifier valid registration with the referrer parameter into my register function, which means that when anyone tries to call the register function, this function first will have to go to this modifier and can only be called if all of these checks are passed. And here I'm passing the address of the referrer, the person who is referring the user. So you will see why. First, what do we check? This is the require statement. It's like if-else statement in Solidity. It requires that this be true. If this is not true, you get this error. This is what require is. Just a moment. Yeah. So here, pardon me. Here we are checking whether the message.value is registration fee, which is 0.25 Ether. What is message.value? It's like message.sender. It's a built-in Solidity stuff. This is the amount of money that is being sent. So it's checking whether we are paying the correct amount of money or not. If not, it throws this error. Then what is, just a moment. Okay, we are rolling again. So here I'm not entirely sure whether this is working or not, honestly. It should have worked, but I couldn't get the idea here because maybe I miswrote it, because we are getting the message sender, the refer of message sender, and we want it to be null address, which can only be in the first user. So we might not use it, but I leave it to you. Okay, I leave it to you. You can check it yourself later on. Then we are checking. You see, this is kind of wrong, weird. So we want the referrer to not be address 0, and you cannot refer yourself. If referrer is not the owner, we are checking here users mapping referrer.refer shouldn't be null address, so like the referrer should exist. Here you cannot, again, pretty much referrer cannot be the sender. Referrer has already referred 9 people. We check whether they have referred 9 people or not, and then we check their level. So it's a lot of checking, but it works so far, if I didn't miss anything. And we used it here so that if any of those checks are if any of those checks fail, this function won't run, and it will show one of these error messages. Now let's continue. Where is it? I'm going to add some view functions that I will use on my front end, and I'm going to explain them to you. These are basically these are the easy parts, you know, because I might want to use these values on my front end. I might want to know about them, what I'm doing. As you can see, get user balance, get user level, get user referrals, get user referrer. These are all public view return functions. As you can see, this one returns to uint 256 and these two return uint 8, because levels and total reference were uint 8 in our struct. And earnings were 256. Basically, when you call this function, it goes to the users mapping, gets the address, finds that user that you are looking for, and returns the thing that you wish. The same. Now we will need to write a level up function, because we would like to level up, you know. Again, this is a payable function, because if oh my god, I cannot speak. If you remember, in order to level up, we have to pay the user has to pay 0.5 Ether. So first we are going to start with a require statement that require that the user has referred 9 people. Yeah, here as you can see, users message sender, the entity or person who is calling this function, level up function in the users mapping, has the referrals of 9. If you don't have 9 referrals, you cannot level up. Then you have to pay money to this function. So we have another require statement, require message.value, which is the value that's being sent, 0.5 Ether. User has not paid 0.5 Ether, will be the error message if this condition is not met. And we have another require statement. Users the user who is calling this function should have less level than 10, because that was the requirement. Now I want my after all checks are complete, I want my user to level up, and I want to reset my user's total referrals, so that he or she can start referring 9 people. Now just 3 more functions, we are done, and then we can go to testing. Okay, it's almost 40 minutes. So we will have a withdraw function, which will require that the person or entity who is calling the function will be the owner. Only owner can withdraw. This function is the you know, when you when people refer other people, they get money, but some of the money, as you will remember, will go to the contract, this contract. So the owner of the contract, you, will be able to withdraw all the money that's collected in the contract, and only you, like no one else can call this function, which is done like this: payable owner transfer address this balance, and it works. I guess, I hope. There are different ways, but I think this one works. Now we need to have a fallback function and the receive function, very important. If you don't have this function, the contract will not receive money. Like, these payable functions won't work, they will give errors, so we have to add these two true. Now we have our contract. This is it. I just wanted to create the name for it, because in a minute we are going to start with testing. I just need a small break, and see you in the next video. Okay, hello again. Now we are since we have written our smart contract, it's time to test it. Here Hardhat has created a test folder for us. I renamed it. It was log.js. I renamed it as Referral.js. I'm deleting everything inside. I'm pasting this. Well, we need to get expect from Chai, which is a test suite, and we require Ethers from Hardhat. So not Ethers from Ethers, but Ethers from Hardhat. And so we are going to write some tests, but I have to tell you that we are not going to cover everything. Oh, I don't have my music. Where's my music? Just a moment. Yeah. Better. Keeps me going, guys. So we are not going to test every single thing. I did it. I'm going to share the code so you can check it. The problem is I have like 300 lines of code, and like this tutorial would take hours and hours if I wanted to test every single one of them. So I'm going to randomly select some of them, and my main point will be to try to show you what I have seen with testing, like what can we test, how can we test, what should we test as far as I'm concerned. Okay, so I'm again checking something and everything seems to be working. So this is basically JavaScript style testing. I want to start with creating some things. Now we are back to JavaScript, so we can just write let. We are writing this, we are going to use them. And like if you know JavaScript testing, if you are doing testing, this shouldn't be difficult for you. Yes, it's an async function. You chill, mate. You chill. All works, no? Ça va pas. C'est quoi le problème? Of course. Yeah. So before each will create something, we'll do something before each and every test suite. We will write inside this describe block, let's say, or scope. So first I want to get the contract referral. Wow, I was not expecting that. GitHub Copilot. So we are getting the contract. Now I want to deploy the contract, referral contracts, await referral deploy. I want to wait for it to be deployed, and I want to get this gets three users addresses: owner, user 1, user 2. I'm going to show it right now. Where are we? On backend now. If we write hh node, Hardhat gives us like 20 accounts with private keys. You see, like this is the wallet address and this is the private key, and they have 10,000 Ether inside, so that we can do testing. So with these get signers, I'm getting the first three, like account number 0, 1, 2, because it starts from 0 index. I get these three accounts because I am going to do stuff with them, you know, like I'm going to I have to check stuff. Like I wrote the contract, okay, but I don't know if it's working or not. So let's start. It should set the music. Where is the music? Where is the music? Yeah, better. Should set the deployer as the owner. Exactly. Impeccable. Owner. Yes. Let's try. Expect await referral contract owner to equal owner address that we get here. I mean, I write hh test and what happened? What's going on? What is this? I might have written something wrong. Let me try. Where did I go wrong? What's wrong here? I must... Oh yeah, oh my god, yes. Sorry about that. Well, I'm already getting the owner. This address here is redundant, that's why it gave error. Let's try again. Passing, all fun. I'm sorry about that. Now, okay, this one was very basic. Let's do something else. Let's register our first user. Okay, it should register user and the first referrer should be the owner. Okay. Now. What is going on here? What is going on here? Let me explain. So, I'm awaiting the referral contract that I have deployed. The thing with Hardhat, the cool thing with Hardhat is that I can, before calling a function, I can connect to a specific address so that I can call the function from that address. And here in this case, I get the contract and I connect to contract using the user one, which is here. We got the signers, which equals to address index 1 here. So the thing is, the deployer is the account 0. This is the default deployer in Hardhat. And I'm getting this user. I'm connecting to the contract via this user because I want to call the register function with the owner address. Why? Let's go back to our register function. What was it? We had an address of referrer, so someone was referring us, and here as user I want to call that function with the address of the owner, who is the deployer and the only user that's this contract currently has, you know, because I'm the first person that they are referring, they are getting. And then I have to pass the value into that function, because as you will remember again, it was a payable function and it has some modifiers, you know, and our first modifier that the message value should be 0.15 Ethers. So here we are giving value Ethers to parse Ether. We have to parse Ether because JavaScript and Solidity, they don't work good with numbers together, and we have to do this. Then let me show you. I'm getting the user again. I'm connecting to the contract that we have deployed. I'm calling the user's mapping here and pointing to the address, which, as you will remember, when we give the address, it points to the user struct, which will take me to user, and so that I can compare the user referrer to equal to owner address, because owner referred me, because I gave owner address as here. I gave owner address as my user's referrer. So I'm comparing whether that's the case or not. Like if so anyway, first let us fail. I want this test to fail. I'm passing an insufficient funds and it will fail. See, tac. Registration fee is 0.25 Ether. Now if we change it to correct value. Maybe I should close this. It should pass. And voila. Next. What should I test? I will test one more in this describe block, and then I will go to the next one because it has been already 10 minutes on this one. I hope you enjoyed. I'm not sure, maybe I'm going too fast, maybe. A lot of maybes. It's, oh, what the, yeah, sorry about that. Should fail if the user is already registered. Yes, async function, please. To play. Again, we are doing this. Await referral contract, the contract that I have deployed here. Contract instance, but connect. I want to connect via user1 and register. The same. I'm doing the same thing that we have done in the previous here, like I'm because all of these are new instances, so I have to register again. And oh no, I said everything I said here was wrong. So basically, since we are already registered, oh no, sorry, again, it's 4 AM in the morning. So since these are all specific instances that are self-contained, I have to register again. And when I register right now, here I'm registered, I'm trying to register again with my expect. You know, I'm expecting when this register function is called again by user1 with the owner address, should be reverted with user already registered, which is here, this one. That one, the one I wasn't very sure about it. Let's, I can't always be sure. Let's try. It's passing. Okay. What I tested in my actually I tested two more things, but I'm not going to write them here. I'm going to pass to another part, another describe block. I tested in this block should fail. It should fail if the user is trying to register with a non-existing referrer. I tested that, and then I tested should fail if the user is trying to send less than 0.15 Ether. Okay, now I want to describe user interactions. Describe user interactions. You know, referral and stuff. Again, let me start with this. What is going on here? The same stuff, you see. I create these variables, and before each I deploy the contract, I wait for it to deploy, and I get the addresses. Now I can write my first test. It user1 can, oh, this is such an annoying one. Yes, yeah, I remember I spent some time with this. User1 can refer 9 users. Yes, they can. That's the thing. Now give me a moment, I have to think about how to explain it. Just a moment. Okay, I'm back and it's recording fine. Well, the thing Now I want to refer 9 users, but I don't want to write every single user by hand. So what I'm going to do, I'm going to give number of users to 11, and I'm going to create a empty array called signers. Why 11? Because I will get 9 addresses from Hardhat, and I already got 2 addresses here. So 9 plus 2 is 11, and this is how I did it. You know, I might be extremely wrong. This might be a very bad way of doing things, but it worked for me, and I'm going to show you how it worked. So here, create 9 users. User index 0 is the owner, user index 1 is user 1. That's why we start from 2 to 11, 9 users. I gave this to my myself as a note. This for loop starts with 2, goes to num users 11. For each user, I give the name, username as such, the user plus the index. I get signer with again index, and I push to the signers array with the username and signer. Let's delete these two. It's not so bad. I mean, I built this 2 days ago. I wrote this 2 days ago or something like that, and I mean, you know, you write yourself, you write the code, but you get alienated to the code that you have written or you had written. So it works. And here for register the 9 users to user 1. For each users, now since we have the users, like I could have just written user 1, 2, 3, 4, 5 instead of that. I just wanted to do a loop. Here we are registering the user 1 to the owner because we want to test the user 1, not the owner. You know, like I deploy the contract, I refer someone, and here I want to test whether the person I have referred can refer 9 people. So we are going one step ahead, you know, above and beyond. So with the signers array, we are doing a for loop. This time it starts from 0, and for each of them, as you can see again, we are getting the index. We are connecting to the referral contact with the address of the user from the index of signers array. So user 2, 3, 4, 5, and with each of them we register to user 1 address by paying the required amount. Let's test it. Let us test it. And it passes, you know. I really like this. You know, each time you do testing and it goes tick, 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 green. I like it. Now we have to do something very ugly. Very ugly. Yes, I'm sorry, I'm not going to write all over again. I'm going to share the code so you can check it again and again and test it. User 1 cannot refer to more than 9 users. So what I'm doing here, I'm basically repeating everything I have done, except I changed the number of users from 11 to 17. So which means I will have more users than 9 users. Here again, until here we are doing the same thing. I could have like we could have done it before the scope, but I didn't. Anyway, repetition is not that bad. It's good for learning. I know there's dry principles, but we are testing. And the thing is here, I'm trying to register the 10th user, which is the index of 9, to the user 1, and I expect it to be reverted with the referrer has already referred 9 people error, because you cannot refer 10 people on one level. And voila, it passes. So nice. Now, let's do level up. User level up. Describe user level up function. Yeah, before each sync function. Yeah. What am I doing? Yes, this is something again very ugly. We are repeating ourselves. I'm going to show. At least let me delete this console logs. Ugly. This is nothing new. This is the very same thing we have done here. We register 9 users. So right now the user has registered 9 users with before each. So which means that each time I write an it test statement, it will start from the user 1 having invited 9 people so that they can level up. User 1 can level up to level 2 after inviting 9 users and paying 0.5 Ether. Let's do it. What do we want? We want to call. If it doesn't revert, if we can call again, we are getting the contract instance. We are connecting via user 1, and this time instead of register function, we are calling the level up function, and instead of 0.25, we are passing 0.5 Ether, so because that's the price that we need to pay in order to level up. Let's try. What the hell? Referral contract is not defined. I forgot something. I did forget something. What did I forget? I know what did I forget. Just a moment. Okay, we are rolling again. Let me see. Well, what I did. Well, the thing is, we are getting the error because I should have put this user level up into this describe. So it's a describe inside describe, because here on before each I deploy the contract, and on the new user level up describe block I'm not deploying the contract. So since there is no contract to interact with, this fails. But when we put everything together, tuck everything together, it passes. Tuck, wonderful. Now, what should we test next? Let me see. User level up. User one can level up. Yes. Okay, I'm going to. Well, normally I tested 2 more things. I'm going to tell you. User 1 cannot level up to level 2 after inviting 9 users and paying 0.4 Ether. User cannot call the level up function before inviting 9 users. And yeah, but I'm not going to write them because, as I said, I cannot write every single one of them. I'm going to go to payment transfer. Let's start with payment transfer. We are still inside there. I guess, I hope everything works fine. Payment transfer. Contractual balance of 0 it initially. Again, we are getting the, let's see if it's gonna pass or not. Yeah. So at first we shouldn't have more than 0 Ethers. The very basic test. Second one, we are going to use something different here. After the initial user, the contract should have more than 0 Ether. So here I'm connecting to the user 1 and registering using the address of owner, and after that I'm getting the balance of the contract. Let's, because with this JavaScript and big numbers and Solidity numbers, they are not really good, so that's why I turned it to number. We can check it, and we expect contract balance to be greater than 0, because now we have invited someone as owner, and when they came they paid some amount of money, which is here. They paid 30% of what they got. This is 0.075 Ether turned into numbers. Can I show it in Ethers? What else? I don't know if this works or not. I want to see. Okay. The numbers and Solidity and JavaScript are quite weird. Oh, didn't work. Let's try this. I'm just trying. I don't know whether it's working or not. I don't remember that. I mean, there is a reason. Most probably why I wrote yes. It's giving value must be a string. You know what? I don't even want to read it. I don't want to bother myself with it. I have written numbers here for a reason, and I'm just going to trust my former self, the past Murat. He is doing good stuff. He's a good guy. I trust him. I'm going to delete this because we don't need it anymore. Now, according to the math past Murat has done, after user 2, user 1 should have 0.175 Ether, and let's check it, because it's user 1 will get 70% of, and this should be the correct number. Again, I don't know. I just trust previous Murat. Here, what are we doing? There is a difference here. You see, first I'm connecting to user 1, and I call the register function with the owner address and pay the required amount of money, and then I'm connecting to user 2 and I register using the address of user 1, and I paid the required amount. Here again we are comparing expect user balance to be this. Wonderful. After that, I tested the contract should have 0.75 Ether after the initial user. I'm not gonna test again. After the third user, the contract should have 0.35 amount of Ether. I'm not gonna test that either. You can find it. You can find it on the GitHub repo. Let's check whether user can withdraw or not. I guess we are still in. Yes. Now. user withdraw or not? Here, what are we doing? We are connecting to user 1 and registering. Then we are connecting to user 2 and registering using user 1. Then I get the contract balance. I'm not gonna get it right now. We are connecting the owner this time and calling the withdraw function, and we are expecting after the withdraw, after all of this, we are expecting the contract value to be 0 because we withdrawed as owner all the money inside, and it passes. Wonderful. And we can see 0 here. So good, so good. And I'm going to test just one more thing. Okay, just one more thing. Just a moment. Just one more thing. Now, describe get user functions works. Like, you know, we had these get user functions, get functions here. So we are going to try that. Can we get the user level? That's it, very basic. You can see it for yourself, and I want it to be equal to 1 because the user level is 1. At first, Ethersjs test, pass. I just love this. Then I test gets the user balance, and that's all, I guess. Again, as I said, I'm going to put the code on GitHub so you can check it for yourself. I hope you enjoyed it. I hope I'm not going too fast. I'm just trying to make it watchable because it's a lot of stuff going on. So see you on the next video where we are going to connect to our application using NextJS and Ethersjs libraries. Okay, ciao. Hello again everyone. This will be the last part of our tutorial. We are going to deal with the front end of our application. Since we wrote our smart contract, we tested it. Now it's time to compile, deploy. Let's deploy. And normally, in order to deploy, where is it? I cannot see it. Where is it? Scripts. In order to deploy, we have to write some things here, and normally we would have to add some configuration to Hardhat too, but since we are going to only deploy into local blockchain, we don't have to write anything to Hardhat config. Just a moment, I'm going to get my deploy script, and I'm going to show you. Let's delete this. This is very basic deploy script. We have a main function. We call that main function. We have done this in testing. You know, it's the same thing we are doing here. So again, I'm going to put this code. You can check it. Now I'm going to deploy this contract by npx hardhat run script /deploy.js network localhost. But first, I'm going to open my nodes. Yes. You see, something happened, and I have this contract referral contract deployed to this address. Now I need to do something. So I will go to my. I will find this artifacts folder that's created with compile. I will find the contracts, and I will get the referral JSON, and I will need to copy paste this ABI because I will need it. This is how I will interact with the smart contract. You know, like in Web3 development, you don't do API calls. Instead of API calls, you have ABI. This, and you can use this to interact with the contract. What do? Okay, we have that. Let's just close this, mate. Let's just close this. Let's go here. Let's create a new folder called constants. Let's create an index.js, sorry, file here. Export const ABI. If I could write above Adam, and yeah, that's all. Now what else do I want to do? Nothing, actually. I want to directly go to my NextJS. Now that's me. First, we will need to install Ethersjs library in not in backend but in the NextJS application. I've installed it, I guess. Let me go again. npm run dev. Let's see if everything is working fine. We are waiting, and yes, it's working. We have a Next.js app created with Tailwind, so we don't have to configure Tailwind ourselves. I'm just going to change some global styles. I did this just today. Yeah. Where is the styles? Global CSS. Yeah. Now we have our global styles. Again, I'm going to put this code into GitHub so you can check it. We are going to index tsx and yes, RFC, wonderful, and I will have to import certain things. Bam. I'm going to show you why that is happening. All good, let's check our, yes, we have an empty page. Quasi empty, and we are recording, we are on live. Let's start. Do I need props? I don't need props, and this should be home. Let me delete this. I'm not going to use props, so it's all fine. And here I'm going to, now we are on the TypeScript part of our application. Why I'm using TypeScript? Because it's always better to use TypeScript than JavaScript, and since we just came from Solidity, we can just continue with TypeScript. So here I'm giving the I put the contract address here. I'm going to show you why soon. And here I'm just defining some states that I grabbed the use state hook. Okay, maybe I should start from here. Sorry about everything. First, we start with importing React use state use effect and mouse event handler from React. We are going to use that. Then we are getting browser provider and Ethers from Ethers. We are getting the ABI that we have saved in this constants index.ts. And no, I'm not getting this. Sorry about that. And then I define certain state values. And again, since we are using TypeScript, we have to define the type of the state that will be getting. And I can start with const connect wallet. Yes. Now the things I will need, I will put a try catch console log error. Now let signer equals null. Let provider if window Ethereum equals null, console log. Let me just copy paste else, because I'm just a little bit lazy. As provider, new Ethers browser provider window Ethereum. It's complaining, we'll see why and we will fix it. Delete this. Console log provider, because we might want to use it. Normally we would not leave console logs. Signer, we might need signer. Await provider, get signer, set wallet provider, signer address. So provider and signer, Ethers documentation explain this. Provider is, I don't know how to explain this honestly. The thing is, when you read, when you just read from a blockchain, you just need the when you just read that data from blockchain, you just need provider. When you want to change data in blockchain, like write something into it, you need signer. And this wallet provider signer address is the address of the wallet that's connected to this contract, which is .our address. The thing is, I'm just going to the return statement. I'm going to copy paste because it will be a lot of CSS stuff, and I don't want to bother myself with it. I will just go over it, but I'm not going to write every single one of them again and again. I'm going to put the code so you can check it by yourself. In this tutorial, my main object was to show the smart contract and how we can interact with it. It should be quite easy. And now again, it's complaining, so we have to do a little bit trick here. I know using any is cheating, but it works. So right now it won't complain, so we just need this. I found this on Stack Overflow. Connect wallet should work. What is this? Close this. Of course it won't work because we have functions that we have to define. When we define all of them, it's going to work. And since I know it's working because I just wrote this code and I'm looking at the code I written from another screen, I'm just going to show you. So with this function we are connecting to a wallet, and here somewhere I put a connect wallet at on click. It should be, I guess. Yes, we are going to go over it, and we have a use effect that does some things. Let's see. And this is not really a front-end tutorial. Again, like, my focus was on the smart contract and testing, but I don't want to stop there. But I don't want to spend a whole hour writing front end here, because this is more like a since we are going to call the register function, which will be we have to pass the type to, like so, because this is TypeScript. This is an async function. I'm going to try to get provider, const provider, yes, but it's wrong. New Ethers browser provider window Ethereum, yes. Now, since this is a register function, we pay something and we register. We put a user into blockchain, so we are changing the blockchain, we are modifying data, so we need signer. Let's get contract. In order to interact with the contract, we need contract address, just here. We need ABI which we get from our constant index.js, this thing, and we need our signer, we get it from here. Then we need to again copy paste. Let's go with copy paste. We are creating a function, a constant called x, which goes for transaction. Yes. We call the register function from the contract with the referrer, which we set somewhere. Where do we set it? We don't set it, I guess. We are going to set it with the input field, because as you will remember, like someone has to invite us, right? And how they will invite? They will give us their wallet address. They are the referrer, and we will pass the wallet address to an input field, and then we will call a register function. And if that wallet address is a valid one, we will be able to register. So where are we? So we are passing that address, and we are paying the required amount of value. Again, we did this in testing, you know, it's the same thing. We just difference Hardhat, I guess. This is I'm gonna show something. You see, like in Hardhat, this is our text split. You see, we are writing value ethers, utils, parse ether. That's because, and here we are just writing ethers, parse ether. The thing is, I guess Hardhat is still using an old version of Ethersjs, old version of Ethers. So this is why we are writing like this. This is how we usually wrote in Ethers 5. But in Ethers 6, the newest version, you don't use utils, you just write ethers, parse ether. So this is the difference, one of the differences. It's basically nothing. I just don't write utils, and that's all. The register function should work. Then I want two more functions. Again, I'm going to copy paste them. Just a moment. I'm putting them on. We're already on 15 minutes. Let's see. We have get level, get balance functions. Let's put them these. I put signer, but do I ever use signer? It's not important. We just want to get the level. Yeah, I used signer here to see the deployer address. You don't really need it because this is a get function. Let's go back. Get level. What was get level? It takes an address, public view, returns uint 8. So this is a view function. It doesn't cost gas. We don't need signer actually. In here I don't even use the signer. As you can see, I just wrote it. We should delete it. I'm not going to delete it, but you should delete it. We connect to provider as we have done. We connect to contract, and then here I'm just getting the address. That's all. And we call the get user level with the wallet provider. This is the address that is connected to this particular instance of our application. So our address in this case. And I'm setting the user level. Here I'm doing the same for balance. I'm calling the get user balance function, and I'm setting earnings. In use effect I'm calling them. Now I will have to put two more functions, which are level up. Again, we have to define, in both of them we have to define the type. Level up function and withdraw function. In level up function we need signer because we are changing the state of the blockchain. Provider, signer, contract. This is the same, you know, we are repeating ourselves. We should get these each and every time. transaction, we are calling the level up function this time. Again, ethers, there are no ethers utils. We are passing just ethers parse ether with 0.5 required amount of money, and I just want to see the receipt. Then we have the withdraw function, which again we need signer because we are changing stuff, and we are calling the withdraw function. Now right now we should be able to see actually. What is this? What did I do? Oh yeah, of course. Switch network. Hardhat. Unblock. So this is how it looks. I know, it's wonderful, right? I again, like, this is not front-end oriented. It should work. And connect wallet. Our wallet is connected, and that's it. Like, right now we should be able to, if everything is correct, I don't know, we should be able to register passing the owner address. Yes. No error. Okay. Yeah, this happens with MetaMask. You have to clear nonce data, and maybe am I with the correct address? Let's see. And voila, we got our stuff. Done. And these, they don't work right now. I must have forgot something. We cannot level up, we cannot withdraw funds, and it gives the correct errors here. We cannot level up because we haven't referred 9 people. Normally here it should show. Let me try. Let me completely do this. Yes, I must have forgot something. It should get level 1, earnings 0, and we cannot again, like, let's try to level up. We cannot because you didn't refer 9 people. Withdraw funds, you cannot withdraw, only owner can withdraw. We are not the owner, we are just a normal user, and that's all. Let me show you very quickly. Here's it. What's going on here? Again, I hope you would check it by yourself. I mean, this is such a basic thing, you know. I don't want to show it from start. I'm using Tailwind CSS. No, this is not correct. And basically we passed wallet provider. This is our address, wallet address. We passed connect wallet. On this input field we are getting the address of the referrer, so that we can pass it here on register function. Then what are we doing? We are getting the user level and earnings. We have a level up button and withdrawal button. This is like the most basic React stuff. And again I'm going to put the code into GitHub so you can check it by yourself. And that's all. We have a working marketing referral or pyramid scheme system. That's all. This was a full stack blockchain development. I hope you enjoyed it. I hope you learned something from it. If you have any questions, if you have any suggestions, if you have anything else to say, please let me know in the comments. And as it goes, don't forget to like and subscribe. So see you in the next video. Ciao.